Okay, good morning everyone, welcome. I think we're going to make a start. Thanks so much for coming. My name is Matt Bates. I'm a founder at a company called Cofide, a UK startup. We focus on workload identity. It's really close to our hearts, and all of the open standards and tools in the CNCF are ones that we use. So pleasure to be back in London. I don't know if anyone can remember back to the last time this was in London, 2016. Just a quick show of hands. Was anyone here at the... Yeah, I thought Ben was, yeah. But yeah, the room, I think the keynote room was smaller than this, much smaller than this, in fact. So great to see how far we've come. So today I'm going to be talking about something I'm sure you've probably not heard much about at the moment, which is AI. No, specifically, we're going to be talking about IAM for AI agents and some of the interesting challenges that it presents. So hopefully this will give you some food for thought. You can see some existing tools, techniques that you can use today in the CNCF. And I'm also going to sort of shed some light, I guess, on some of those challenges and some of the ongoing efforts within the CNCF and beyond for solving some of these challenges. So it's hopefully super useful for you today and to take away with you. So I guess we've all heard about AI, we all use it. Quick show of hands, in fact, is everybody using AI here? Is everybody using generative AI? Yeah, okay, I probably don't need to ask. So we're all very used to using like generative AI, generally speaking. Yeah, a lot of us now using it for coding. I do probably more vibe coding than I probably should be doing. But we're all finding it incredibly useful in our daily lives, and I think by the day, by the week, things are changing. Really what I wanted to focus on specifically are agents. And yes, this is some generative AI from OpenAI. You might notice a few of those throughout the talk. But an AI agent is one that's more autonomous, right? We give it a task, and rather than just relying on sort of some of the generative AI we've been used to, where we engage in a conversation, it responds to us using an LLM, gives us some kind of text or some kind of other media. The agent can actually have some decision-making and some reasoning capability, so it can actually understand the task that we're asking it, and can go away, much like a human, and can reason about all the things that it has, its memory, its sets of tools that it has access to, which we'll talk about, and go off and actually do the work necessary for us, which is incredibly exciting, right? We can ask it to do tasks that are otherwise quite labor-intensive, and we can give it the information that it needs to make those decisions. So lots of autonomy, that's the important point. The ability to interact with the environment, I think this is quite unique. So rather than just referring to a trained LLM, where perhaps the knowledge is perhaps out of date, it can rely on providing it some extra information. It's goal-oriented, and it's got some memory, and we'll talk a bit more about this. So I think one of the places I would recommend reading, if you haven't already, is Building Effective Agents by Anthropic. A great read. It talks about all the various different models that they're seeing, and of course this is evolving all the time. But I really like this description that it uses, which is it describes a type of agent as an augmented LLM. And I think that's a really good way of putting it, which is effectively it takes input and it has access to a variety of things which can complement effectively its response in order to really drive towards the goal of answering our question or delivering on the task that we ask it to do. And those are mostly retrieval. So retrieval has been around for some time. We've always been able to add sort of so-called RAG, where we can take some existing knowledge bases that we have, maybe internal knowledge bases, and we can complement the LLM. So we can give it some somewhat organizational specific, domain specific knowledge that it can use. And so that's actually been something we've been able to do for a little while. We've also been able to provide it with the ability to have memory as well. So rather than having to go to the LLM each and every time, you can actually use a memory caching layer, and this can obviously save on tokens, which is pretty advantageous. But it can also remember the insight. It can remember the context of the conversation that we're having with the LLM. But what is interesting now is that we're beginning to see these LLMs be equipped with tools which we can provide it access to. And there's a lot of, I'm sure you may have seen some of the work that's being done with MCP, which is a protocol that's being championed and being developed in the open by Anthropic. But what it enables you to do now is to start plugging in these tools that we have. And that's really quite interesting because we can start giving it access, not just to a corpus of material, but we can also start providing it access to things like APIs things like databases, our actual systems. And so we can actually ask the LLM to call those and actually use it as we would, right, as humans, or as other systems would, which is really good, which is really exciting. And so, specifically thinking about tools, well, they have very specific functions, right? Just much like APIs. They can be called when required, which is really interesting. So the LLM can reason about the task, and then it can decide when to use these and at the right time, and it can interpret those results. It's responding in machine code. It's returning messages that can then be interpreted by the agent. And they can be used for particular tasks, integrated into the workflow. But effectively, what they're doing effectively are the tasks that we would be doing, but in that kind of loop, and they're determining when it's needed. And so I sort of thought, okay, well, hearing a little bit about this, particularly from some of the partners that we're working with, all right, actually, how would we go about building one of these? And actually, how would we think about, and this is where we're going to get to in this talk, is how would we think about securing these things? And so, yes, like everybody else, I vibe coded something rather rapidly, not something I would think about putting into production. But I sort of thought, if I was to do this, and I was thinking something quite canonical, so to keep things simple for the purposes of demonstration. But if I was to build a chat agent, a customer service assistant, we're all probably used to using these or trying to engage these. I think some of the legacy versions of these chatbots have been really frustrating. I don't know about you, but whenever I've tried to engage with them, it's been a really frustrating experience. They often don't understand, and normally speaking, they end up just basically sending you to a human operator to deal with your inquiry. But I think with the advent of some of these newer generation models and LLMs, I think we actually have the ability to really enhance those agents quite significantly. And we can give them access to information, real-time information, that they can reason about, and actually provide a really sort of meaningful response to us as a user. And of course, that will hopefully be really assistive to companies. So I thought about building this one, and what I wanted to do is attach a couple of different tools. Also, you may have heard these referred to as functions as well. And so I very simply wanted to represent an orders database. So if I wanted the customer service agent to be able to respond to me, understand my request, and go off and actually check up on the order itself and also the status of the order, I wanted to give it access to APIs that it could use to do that. And in my case, I used, there are obviously lots of choices here, but I plugged into Vertex AI with Google, and I used the Gemini Flash model, of which, of course, there are many. And this is the prompt that I gave it, so I gave it a pretty reasonable prompt. I mean, really wanted to give it its role, understand what it was doing, and how it would go about achieving that as well. And so I gave it a set of tools. In this case, kept it really simple, like get orders and get order details that it had access to. So informed it about those tools and how it could use them, and the sequence that effectively it should follow. So I must say I'm a beginner at these prompts, so I'm sure there's better that I can do. Come and let me know later if you think there might be something to add and to enhance this. In order to actually build this, there's a variety of different frameworks that you can use, and I think this changes by the week. Yeah, there's lots of new tools in the open source that you can use to build these agents. And I mean, very simply, you could build one without a framework if you really wanted to. But I thought using a framework might be really useful. LangGraph is from the LangChain project. So if you're familiar with using LangChain already, LangGraph is your ability to go build out a graph-based agent. It's not quite a DAG because it has these cycles, which are really useful. So you can have the chatbot determine the tool that it needs to use, and then it can choose to use multiple tools, right? It may choose one that may fulfill the request of the user, but it may also need to review the response from the user and then actually go away and use another tool. So this actually suits that pattern really, really well. It's built for that. And so that's a kind of very simple representation of what it looks like, right? It has nodes, it has edges. The nodes are the components, effectively. The edges are the decision-making edges, if you like, pretty much. So pretty simple to build this, and you can build this in Python, which is what I did. There are other frameworks around. I think notably there's, AutoGen from Microsoft as an example. There's Kuru AI. There's all manner of them out there. But I used LangGraph to do this. But what I realized is that when building this, and sort of putting my sort of security hat on, I realized that I was storing up a huge amount of risk when building this prototype. Very easy to get started locally. I could build this on my machine. I could give it all the tokens that it needed access. But actually, if you were to put this into production, there are lots of concerns. And hopefully, I'm sure some of you may have already come across these as you've been building agents when you've been putting it into production. The security teams will be asking you, have you thought about authentication? Have you thought about authorization? And the answer to that may be no. So really what I wanted to think about here is like, what are the things that we need to consider, but also like how might we go about using some of the CNCF tools to do that? Pretty much. So number one, well, we've got this risk with the token that we use to access the LLM for a start. So normally, this is a very long-lived token. You are downloading it from your provider, you're giving it access to your code, and then forevermore, you might well be using the same token until such time you rotate it. But yeah, generally speaking, it's long-lived. So number one, that's kind of the cause of concern, particularly if you're putting it in an environment that's not yours, right? Okay, on your laptop, where you have protection of that key, but as soon as you put it into another environment, this is a concern that you're going to have, right? Which is that number one, it's available to other workloads potentially, and it needs some form of rotation. The other point is also around the tools, and this is like of particular interest here. Like we are now giving the LLM the ability to recommend the tool that it wants to use, and then go actually call it. Pretty much, it would inform the agent. The agent will actually do the work of going to that tool, perhaps interfacing with an API. But we now need some way of being able to identify the agent. And we've got the challenge of identifying the user as well that have made this original request, right? But effectively, it's being made on behalf of that user. So this is really challenging. And I think a lot of the examples, certainly a lot of the examples I've seen online, generally, they don't really have concern for this, right? They have just pretty open access to these APIs. Just like you point it at a URL, perhaps you don't even have any form of authentication at all. And certainly no form of like very fine-grained authorization, where you're limiting the access that the agent has to the data that it should be able to see to fulfill that request, right? It shouldn't have access to the entire orders database. It shouldn't have access to the entire customer database. So that is a concern. So how do we do this in the CNCF? Well, we've got existing tools and standards, right, to do this. There's a lot of things that already exist. There's a lot of open source projects that can help us to plug some of these gaps, right? We can choose to use them to help us to get so far. There's some challenges still, which I'll highlight, but for the most part, we've actually got a number of these. And these are just several, right? There's the CNCF landscape looks huge, and there's a large number of them that I'm sure we could also employ. But these are certainly the ones I've been familiar with that I've decided to use here. So one notably that I want to talk about is SPIFFE, and this is something I've been working on with for some time. Just a quick show of hands. Is anyone familiar with SPIFFE? Is anyone using SPIFFE? Wow, okay, a good number of you. Fantastic. Okay, so for those of you who don't know what SPIFFE is, it's an acronym, of course. It's a secure production identity framework for everyone. It's a relatively mature open source project. It's actually one of the graduated CNCF projects, and it's used by a number of end users in production at scale. It's a set of standards, so you might be familiar that SPIFFE is the standards, the APIs, and SPIRE is the reference implementation. So if you want to go to choose to use this today, SPIRE is what you need to go and use. And actually, under the hood of all of this, I'm using SPIRE as well. It's powering some of the identity, which we'll see shortly. So the different aspects to SPIFFE, I won't go into a huge amount of detail. There's some great talks that cover this at previous KubeCons. I'm sure there will be at future KubeCons too. But just at a really high level, what does it provide us? It provides us like APIs and standards for being able to identify software and for a given identity. So it's got a set of APIs for issuance. It's got a set of APIs for being able to validate that identity, for being able to federate it between different environments, and then ultimately how you represent that cryptographically. And we'll see there are two different ways to do that currently in the project. Ultimately, it lands in an X509 certificate or a JWT token. And we'll see how we can kind of use these throughout. Just at a very high level, how it works for anyone that's not already used this, not already aware. It introduces, basically has a server agent architecture. And it differs from some of the existing techniques that you might be familiar with granting identity at the moment, in that you don't give long-lived access keys. This is something that traditionally we've been used to doing, right? It's minting tokens and putting tokens into our code, perhaps, and obtaining it from a vault. But instead, it enables the workload to talk to a node local agent. This is like an agent that runs on every one of the nodes in a, say, Kubernetes cluster. And the agent is then responsible for basically doing a process of what's called attestation. It's a process of like proving the workload's, if you like, provenance. And the agent's able to do that using a variety of means. It can do that by looking at, for instance, the Kubernetes API, which is a, if you like, a source of truth. Is my workload, has it been registered with the API, and now does it exist in the place where we expect it to be? And there's other forms of attestation that it can do. But the point being is that that is done out of band. The agent runs out of band. It's able to prove something about the workload. For instance, you might even want to extend it to whether the container image has been signed. There's a number of different attestations that you can apply. Those attestations are then validated against the server. So you basically provide those proofs. The server matches those up with what it expects, whether it expects this workload to be running in the place that it has been provisioned. And if all that matches, then that's the point at which the identity is then granted. And the identity is then given to the workload. So the workload itself is not actually having to do anything, right? It's just referring to this node local API. It then obtains the identity, and then it can use that identity thereafter. And the important point is it's short-lived, but it can use that identity then to establish secure communications with other workloads in the system. You can either use the X509 to establish an MTLS connection, and it could also use the JWT as well to convey its identity, right? Effectively, it's a credential that it can use. So this is a really high level anyway. If you're interested in reading more, Solving the Bottom Turtle, fantastic book that talks through a lot of the motivations for the project, the history, and the architecture and how you would go about using it. How would you use this in practice, and how did I use it in practice? Well, once you actually have this identity, you can then start using it to make secure connections, and you might well do that in your own code. And so you can use the SDK that the SPIFFE project provides in order to integrate it into something like Go, for instance, and Python, which is what I used in my case. But you can also use proxies to do this for you, right? So you may not want to build those smarts into your code, but you can have a proxy do it for you. And so something like Envoy supports SPIFFE out of the box, right? It's got the ability to obtain those credentials via the STS protocol. So that's already built into, obviously, Envoy, built into Istio as well. And this is how Istio indeed obtains its identity for all its workloads that runs in the mesh. And so this is now going to enable us to establish these secure connections. Really important point to make here is that we've also now got the ability to encode the service ID into that cryptographic identity. And so we've got, and you can probably see here, this so-called SPIFFE ID. This is a way of representing the identity. And you can choose to represent this in whatever way works for you effectively. But everything lives within, in this case, a trust boundary or a trust domain. So the myorg.com example there that you can see is a so-called trust domain. And everything within that then can be given an identity. And that's up to you how you kind of decide to do that. And so people carve these things up by perhaps their environment, perhaps they might want to give it some key value pairs that represents the labels of the workload, however you want to represent it. But the good thing about this is that now that it's encoded in the cryptographic identity, the X509 certificate, the JWT, is you can start using that ID meaningfully. So you can start basically authorizing requests based on that ID, which becomes incredibly useful. So how would you apply SPIFFE to sort of this agentic architecture, right? How would you take SPIFFE and use it in the example that I have? Well, the workload, when you think about it, the agent itself is a workload, right? It is effectively something that is going to run potentially in a Kubernetes cluster. It doesn't have to be, but it is just a workload. And so we can actually start just plugging in SPIFFE here and using it in conjunction with SPIRE, right? We can give each of the different components in our system a SPIFFE identity, including the agent and including the tools. And so now what we've got are unique identities. They're given them as they're kind of provisioned in the system. We can scale them, of course, and we've got the ID encoded in that credential. So first port of call is, right, let's just credential everything in our system, right? Let's give it some kind of ID. Let's make sure that this ID is short-lived. We don't want to have the job of having to rotate this ourselves. And we certainly don't want tokens that are long-lived that can then be discovered and potentially exfiltrated from the system. So this is already increasing our posture quite significantly, right? From the first vibe-coded example where I built this, and it didn't really have anything in the way of any protections. So this is like applying those credentials. The other thing that SPIFFE provides, or certainly SPIRE provides, is it can also operate as an OIDC provider. So you can actually have validation of the tokens that it generates and then mints and gives to the workloads. And so I also used, in this particular example, the JWT SVID tokens. And those are given to the tools or the agent. And the agent can then use that to make a secure connection to something like Google Cloud. So the way you might do this out of the box is using a long-lived service account token. You can avoid that. You can replace it with the JWT SVID. And then you can have Google, or any hyperscaler for that matter, but you can have it configured to create a trust relationship with your SPIRE OIDC provider. You can host that, the JOCS endpoint. You can then have the trust relationship established, and that will mean that Google or anyone else will be able to trust the tokens and be able to validate those tokens, importantly, and give access, in this case, to Vertex. So I was able to create an integration here where all of the long-lived tokens pretty much were removed from this architecture. So everything was shorter lived. So let's see this kind of in action. I don't know when we're going to do this live because you never know quite how the Wi-Fi is going to work out. So this is just a pretty canonical example, right, of creating a chatbot. And if anyone's seen this before, they'll probably be quite familiar with it. But yeah, this is me having the conversation. But incidentally, you can have real fun with these chatbots. I probably should maybe I should have included some of the examples of where you can really push the LLM and start to ask it a little bit more than it's willing to give up. But anyway, let's kind of stick to the script and follow it. This is me talking to the chatbot. And you can see here, and I'll probably just pause it at this point and hopefully hover away so you can actually see it. But yeah, what we've made a request to the chatbot. The chatbot has reasoned about the question that I'm asking it, and it's now referred to the tools that it has access to, right? So in this case, pretty simple. It's got 2 APIs that it can use. It's determined that in order to answer my question, it needs to go and use one of these tools, which is the getOrders API. And so it's responded with a request to use that, and the agent is now able to go off and actually make that request to the endpoint. And so I can continue the conversation. Yes, it's that particular order that I'm interested in. And then it will go away and actually fetch more details about the specific order. And yeah, we'll wait for it. Oh, yep, and there it is. And so at this point, yeah, certainly the chatbot could become a lot smarter, right? It could go and actually obtain the information from another delivery agent. So the point being here is it could hand off potentially from one agent to the other. So yeah, certainly more smarts could be added to this, that's for sure. So that's the example. What I wanted to talk about, though, is not just how we can think about the workloads themselves, right? We've managed now to give identity to each of the different components in the system, but really, how do we encompass the user identity? So I was making a request to this agent. The agent should really be using or have some notion of my identity when it makes the request to downstream systems. What it shouldn't be doing is just having completely open access to our internal systems, right? I mean, particularly if the prompts could be engineered to perhaps do things that perhaps it shouldn't be doing. And actually, there are recent examples in the last few days where that's been possible with the likes of things like MCP, where you can actually ask it to do things which are similar to the brief that it was set, but pretty nefarious. And so, yeah, this is what you want to avoid. And if we follow all the principles of zero trust, what we should be doing is taking not only the workload's identity, but also the user's identity as well, and using that combination to make a really fine-grained decision of the back end. So what I did here is I integrated DEX, and you might have noticed this already did have some login. So it did already know about me as a customer. And it was able to pass that through. So nothing sort of unusual here, right? I was just using standard OAuth JWT tokens, using OIDC in case of DEX, and I was able then to pass that through to the agent. The problem is, though, what you won't really want to do or shouldn't be doing is then propagating that JWT, right? That has specific intent, and it has, of course, all the access that is attached to that user. So what we don't want to be doing is just basically taking that JWT and then passing it through the system. What we really want to be doing, ideally, is we want to be attenuating that access. We really want to be attenuating to, we kind of make sure that ultimately when the call is made to the order database, that it's specific to the user, right? The agent is not possible, it's not possible for the agent to start seeing things that it shouldn't be seeing about some other customer. And in some of my early examples, I did find that it was pretty straightforward to do that, right? You could instruct the agent to go ahead and tell me all like orders in the database, regardless of the customer. And of course, it was very willing to do it because it had the access to do it. So how do you do this, right? Well, one approach is that you could, as I said, you could literally take the JWT and you could propagate it in a header. So you've already got mutual TLS. You could, again, use the JWT and just pass it through. The problem you have, of course, is one of like token replay. Ideally, with these things, you shouldn't be taking something like that and passing it and propagating it through the system. Particularly now, as you're giving something like the agent access to that token, right, that it could use in, well, hopefully good ways, but potentially more nefarious ways. So there are some interesting projects coming about that might help us to address this. And this is not in the CNCF, this is in the IETF. There is an OAuth working group, and there's a number of interesting projects and standards that are in development. And one that sort of took, I guess, took my interest for solving this problem, potentially, is something called OAuth transaction tokens. And so what this enables you to do is it enables you to take the user context and the request context and effectively encapsulate that in another signed token. And so this is really, really useful because it enables you to, at the point of entry into the system, for instance, some kind of gateway or proxy, as your user basically passes that trust boundary of being external or internal, you can grant this new token type. You can mint this new token type, which has all the context that's needed for the downstream systems to be able to make a decision. So there's an early implementation, which is called Tokeneddies. You can go and find this. It's pretty early. It's an implementation. And the actual transaction token or the track, is still in draft. So it's probably worth noting this is not a standard yet. It's still in draft. And so if you might be familiar with Beyond Prod, perhaps, you might be aware that this looks a little bit like, or perhaps inspired, by the end user context token. And so the way that Google operates this is broadly similar, right? It kind of enters the Google front end. The Google front end is responsible for doing user authentication, and it then generates that end user context token, much like this transaction token. And then that gets propagated through the system. And that can go through the entire call stack until it reaches, ultimately, the microservice that will be delivering you the data and fulfilling your request. Pretty much. So yeah, maybe perhaps broadly inspired by that. And so just at a very high level, I heard the claps next door, so it might mean I'm running out of time. How does this integrate? Well, you effectively use it at the point of entry into the system. So as the request is made into your system, you can use a gateway. I use just a Go reverse proxy here. And yeah, you could use Envoy, you could use all manner of different proxies to do this. But the point being is that it then integrates with this transaction token service. And the input of that transaction token service is the access token from the user, the one that effectively is passed from the client. You can use that together with the identity of the gateway itself, because you want to obviously apply some kind of validation to this request. And what is then given back or minted is a very short-lived JWT signed token that is specific to that user and, importantly, the nature of the request that's been made. So you're basically saying, at this point in time, this user very specifically wanted to fulfill this purpose. And it's that token, that, if you like, attenuated token, that you can now start passing through your system. No longer do you pass like the original access token, pretty much. So this is moving us towards a model of certainly maturing our zero trust, applying our more zero trust principles to the system. And now, importantly to point, is that your agent, your tool, can make a very fine-grained decision, right? It has access to the original workload that made the request, and it also has access to the user and the context. So it can evaluate all of this, and you can use like policy to determine whether it wants to respond to this request or not. Just very, very quick look. I'm sure I can let you go read a bit more detail online about this. I don't want to run out of time, as I'm sure I have already. But this is like effectively what one would look like. It's a draft, so clearly things are changing all the time. But the point being is here, though, you have the transaction identifier, you have the context of the request, you have the transaction context and the purpose. And so this enables you to use this and validate it much like you would any other JWT. So really what I wanted to show is that by employing some of these existing tools and techniques and also some of the sort of standards on the horizon, we can move from a model of like one of just completely implicit trust, which is where I started, I guess, with my vibe-coded prototype. And then I incrementally added these capabilities. So I enabled service-to-service trust using SPIFFE. I could credential everything. I could give it short-lived cryptographic tokens or certificates and tokens. And I could then complement it with user trust, right? I could start bringing into this the user and the context of the user and the request. And I'm running low on time, so I'm going to flick through these next slides. Happy to share these. What I wanted to draw a little bit of attention to, and would recommend you go and read up a little bit more about this if you're interested. But there's a lot of interesting work that's going on in the IETF, specifically a group called WIMSE. They're trying to standardize on a lot of these things. There's a lot of new token types, which will be really interesting to solve some of these problems, particularly when you're actually passing across trust boundaries. My example today was relatively simple. Like everything was within a single trust domain. The reality is that, of course, you would be spanning workloads across different trust boundaries. And so you would need to be propagating these tokens, not just within the context of that domain, but potentially across domains. And so, yeah, a variety of work going on in WIMSE, and also the OAuth groups as well. Some pretty interesting challenges, for instance, around what happens when the agent needs more privilege, right? What happens when it needs to actually go access a system and it needs the user's permission to do that, right? That's a sort of super interesting problem to go solve. So just in summary, and apologies for running over, agents are really just effectively smart workloads. That's really the best way to think about it. We've got existing ways that we can credential. We've got existing ways that we can apply authorization to this. Lots of tools and techniques for doing this in the CNCF. Some interesting challenges on the horizon. If this interests you, please get involved. These groups are all open to participation. If you're an end user, perhaps you're from a vendor, perhaps you just want to get involved regardless. Like this is something that interests you, please do. We're going to need more blueprints. We're going to need lots more best practice around this because AI is certainly coming at us pretty fast. And so these challenges are going to need to be something that we're going to solve really soon. So that's me. Thanks so much. Thanks for coming today. If you found it interesting, or indeed if you didn't find it interesting, please give some feedback. It's really, really useful to know. That's the QR code, I believe. It's the one I was provided. So hopefully it works. Yeah, but if you want to give me some feedback, please do. And I'm going to stay behind. I'm a little over, I overran a bit on time, so I'll probably just take questions here. So if you want to come ask questions, please do. I'm really interested in any kind of real-world use cases that you've got, and perhaps if some of these things are something of interest to you, please let me know. Thanks so much.